Hard because of the stuff you did, or was it hard because of the stuff that you did, but their questions were hard? Alright, so stuff that you've never done before, I agree. I've done it. If it's something that you've done and you're supposed to know how to do, that's different.
It's terrible.
Good morning, ladies and gentlemen. I hope everybody is doing well this morning. Your pencil now goes down, your colored pen goes up. Today's warm-up is a review, a total review of concepts from the distant past. Let's see how we did with these concepts. So, I'm going to be calling on quite a few people. Here we go. For number 1 and number 1 only, I have student 22 and student number 1. Student number 22, what'd you get? Okay, student number 1.
6x.
So you both agree that it is 6x, which it is. Number 2, I have student 24, 7, and 11. Student number 24, what do you say? Student number 7, what do you say? Student number 11, what do you say? So 3 of you agree that it's 10y, and it is. Number 3, I have student 19, 12, and 3. Student number 19, what did you get? Student number 12. Student number 3. So 3 of my students agree that the results should be 3p. Number 4, I have students 13, 14, and 15. Student number 13, what did you get?
6n to the second power plus 5n.
Student number 14, what do you say?
5n plus 6n to the second power.
Okay, student number 15, what do you say? I will accept both of those answers. 5n plus 6n to the second power. Actually, I'd say 6n squared plus 5n is probably even better, because that's putting it in standard form. Number 5, I've got student 10, 18, and 4. Student number 10, what do you say?
20p cubed plus 11p squared.
Okay, student number 18.
20p to the power of 6 plus 11p squared.
Okay, so that's a disagreement. Student number 4, what do you say?
20p cubed plus 11p squared.
So it comes out to 20p cubed plus 11p squared. And number 6, what do we get as a result of simplifying that? I've got student 5, 21, and 6. Student number 5, 21, and 6. Student number 5, what'd you get?
5x squared minus 3x plus 2.
Student number 21, what do you say?
5x squared minus 3x plus 2.
I think that's the same thing. Student number 6 is not here. So we got 5x squared minus 3x plus 2. So we had 6 questions, all review. Make a fraction out of 6. Hopefully you got 5 out of 6 or better, which would be about an 83%. Got all of them right, that's wonderful. You got 4 out of 6, doesn't make you a bad person, it just means that we need a little bit of review. So now, we are at an interesting juncture because now things you learned in the past and things you learned very recently start to get confused. And so, for example, Amir offered up that number 5, the answer should have been 20p to the 6th power plus 11p squared. So let me write down the 20p to the 6th power. Can someone tell us what mistake was made in this case that led to the wrong answer? Amari, I apologize. Okay, so we're adding this expression to this one. So we're adding 12p to the 3rd and 8p to the 3rd. So we add the coefficient. And then some of my students, now thinking of something new, start saying, oh, well, I'm supposed to add the exponents. Because you did learn that you're supposed to add exponents in a certain case. What case are you supposed to add the exponents? Catalina? When you're multiplying. And so now we have an issue. We have to remember when to use which rule. And it can be confusing because this is math class and it's really not too much fun. But I'm going to use a semi-fun analogy. Give me a thumbs up if you are familiar with basketball. Even if you've never played it, you just know what it looks like and you could understand someone was playing basketball. Good. Keep your thumb up if you could also say the same thing about baseball. Never seen baseball ever? Oh, you've seen it, you know what it is? Good. Put your thumbs down. So I want you to imagine that someone is going to try out for the baseball team. And they walk out onto the field and they pick up the baseball from the ground and they start dribbling it. And then they pick up the baseball and they shoot it like that. How's that going to go over with the coach who's trying to figure out which players he would like to take? What's he going to think of that person?
The coach can get knocked out because baseballs are very heavy.
That's true. So we want to be careful, but keeping in the spirit of my question, we're going to say that
The player doesn't know what he's doing.
player doesn't know what he's doing, because what is the player doing? He's confusing the...
Basketball and baseball.
So now, is there a rule somewhere that says take a ball and do this with it?
Yeah.
Yeah, there is a rule, right? But it's a basketball rule. It's not a baseball rule. So you can't take a basketball rule and apply it to baseball, right? And can you take a baseball bat and take it to basketball practice?
I mean, yes, you can.
And when the person throws a pass to you, you swing away. Basketball goes flying across the gym. So there is a rule that says take a bat and swing it like this and try and hit a ball. But it's not a basketball rule. So you're not allowed to take rules and cross them over, are you? So while I understand math is, for many of us, not fun, and basketball and baseball maybe is fun for some of us, the point is still the same. You can't take rules and transpose them into any situation you want. One of your jobs is to know the difference. Just like if you were an athlete, you would need to know the difference between basketball rules and baseball rules. Some rules get very complicated, just like in sports. There are some very intricate rules about what you can do at a specific moment and what you can't. You don't have to know every tiny little rule right now, but there are rules that you have to know, okay? So that's where we're at. Now it's getting confusing, because now it's like this. Now it's baseball and cricket. It's one of the most popular sports in the entire world. It may not be popular for you, but there's a sport called cricket that actually resembles baseball. But the rules are different, but they look very similar. There's a bat in cricket and there's a bat in baseball. There's a pitcher in baseball and there's a pitcher in cricket. But the way they do things is very different. And so you would, if you liked both sports, you would have to know the difference. If you went onto a baseball field, you would have to know that the bat is a round bat, whereas cricket, it's flat. You would have to know that when you pitch in baseball, the ball has to go from the pitcher's hand to the catcher's hand for it to work. In cricket, they bounce the ball. Do we bounce the pitch in baseball? No. So now the rules are similar, but you have to know the difference. Okay? Any questions? Good. So keep that in mind as we work through today. Okay. So you already titled today's lesson, Lesson 6-4, and its subtitle is, of course, Adding and Subtracting Polynomials. We are introduced to this idea when we did the exploration the other day. And so that was a lead-in to what was going to be explored today. So here are your notes for today.
So nice.
And so I intentionally put nothing here to send a clear message that you already know everything you need to know. It's a matter of context. Context means take what you know and apply it in a situation that maybe you've never seen before, but still applies the skills in the same way. So there's nothing new to learn per se, it's just new situations to pay attention to. Any questions about that? Good, so we're going to jump right in. I am taking the approach today of doing the most challenging questions up front, and we're going to gradually work in some moderate level questions as we go along. But none of them are really super difficult because they don't require a huge amount of thought. It's more about detail.
Oh, there's no more leaving.
Now, yes, for examples, you have to write the whole thing. And so that can be a little bit of a pain, but it's not that big a deal. And in example 1, we're asked to do the following. Find the sum and write it in standard form. Standard form is now a term that's in your mind and it means something. So it tells you how to write the answer. If you don't know what it means, then you need to pay attention, talk to a teammate, ask questions of me, that's fine. But when you walk out of the room today, you should be very clear on when I say standard form, you know exactly what I'm talking about. Now, I want to pause for a second and I want to look at a very simple example of something related. So I'm going to wipe this out quickly, just to hide it so we can focus on something else. I want to put something up here. I would like you to mentally find the answer to that. Give me a thumbs up when you've got it. So I'm assuming if you don't put your thumb up that you're having difficulty doing that, and that's fine. I'm just want to be clear. Okay, Jesse, what does it come out to? Okay, he says it's 10. Give me a thumbs up if you agree. Okay, a lot of you agree. Yes, it's 10. Okay, so now I want to do something. I would like you to now mentally find the answer of that. Give me a thumbs up when you've got it. Chanel, what does it come out to? 10. Give me a thumbs up if you agree that it's 10. Okay, so yeah, it is 10. So now I want you to watch something. Why is this 10 and this is 10? Because parentheses are supposed to do something for us. Why getting the same result? So we got Tristan, Catalina, Gary.
Well, if it was just a parentheses and 2 didn't have some between it, then we just close it. But since it has them, just do it as right. You just do the parentheses first and just that's it.
Okay, good. Catalina?
Well, if it has a parentheses instead of plus sign in the front, then that means it is either the one, so you distribute the one, and you just put it without the parentheses after.
Okay. I like how you brought in the distributed property. That was a good idea. Gary?
Parentheses really only matter when there's multiplication and division.
Okay. Okay, so we've got some interesting statements. I like what Catalina said, I like what Gary said, I like what Tristan said. They're all correct. Let's talk about what Gary said. I don't know if he's 100% accurate, but I like the way he said it. Because I was going to say something similar. I wasn't going to say that it only matters with multiplication and division, but I was going to say that in this case, the parentheses don't matter because they're not really doing anything except grouping. It's actually not affecting the outcome. In this case, yes, technically we're supposed to add this first. However, if we do this, it ends up the same, so the parentheses don't matter. Okay? So I like how Catalina pointed out that the plus sign is here. And that's really what's going on, is that everything's being added. Had the plus sign not been right there, then that would imply multiplication, and then the parentheses mean something. Okay? So by contrast, this, the parentheses means something important. Because this now says multiply this times this and this. But here the parentheses are not really saying anything at all. So now, what am I talking about? Let me back all the way up, back to the original. So this is where what they all said was really important. These two, this is an expression that represents something. I don't know what it represents, but it represents something. This is an expression that represents something, and we're going to add them together. And if we look on the inside, it's just addition, 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 and addition.
What?
I know that that's a subtraction sign, but of course you already know that addition of a negative number and subtraction is the same thing. So subtraction and addition are really the same thing. And so when you notice, it's everything's being added. All these terms are being added, which means that these parentheses don't impact the outcome at all. And so we can just, even though that was intended as, this was intended as an expression, if I just drop the parentheses, now we can look at this whole thing as one giant expression where we need to simplify. And you already know how to simplify. That's why there was no notes today. How do we simplify? Oh, I didn't want to do that. How do we simplify all this? Well, what can we start with? Yes? Combine like terms. Can you give me some like terms, Yasmin?
11x squared and 12x.
Okay, so we've got 11x squared, and we've got a 12x squared. I love how she zoomed in on that, okay? But hold off for a second. We are going to combine those, but now I want you to look at this. We are asked to write in standard form. When we write in standard form, what's supposed to come first in our answer? What should come first? Cheyenne?
The largest power or
Yeah, I mean, it's supposed to be the largest degree, but for the most part, it's going to be the largest power. So Yasmin's right. Those are like terms, but let's do both things at the same time. Let's combine like terms, but let's pay attention to the order that we do it so that we get it in standard form right away. So what should be the first term we look at? Where should we start, Tyler? X to the fifth power has the highest power. Does it have any partners, Tyler? Has no partners, so it's not going to get combined with anything. That just means we rewrite it. We're done with that. What's the next highest exponent? Next highest. Michael? Negative 2x to the fourth. So we've got negative 2x to the fourth. Does that have any partners? No, it doesn't. Okay, so that doesn't have any partners. So we're done with that. Minus 2x to the fourth. What would be the next lowest, next highest exponent, Gary? Negative 3x to the third power. And does that, Gary, have any partners? 7x to the third power is a partner. So now combine those together. Combine that with that. What do we get? Here's the key. What do we get? Laurel? Very good. We get 4x to the third. Because when you combine like terms, you don't do anything with the exponents. You leave all that alone. Very good. So now we're to Yasmin. Yasmin, you pointed out 12x and 11x squared and 12x squared. What do we get when we combine those? We get 23x squared. And we're done with that one and that one. And what's next? Adriana?
Negative 8 squared, negative 8x, and 8x.
Negative 8x and 8x. Okay, and when we combine them, we get?
X.
we get x.
So it's
Negative 8x and 8x. We get x. Negative 8 plus 8 is 0. So why do we get x?
Because there's still that, there's still variable.
That's true, but there's a 0 in front of it.
So you just,
So we could write like this. Is that what you mean?
you could, but you don't have to.
You don't? Is that the same thing as that?
Yes.
Ah, so we have a flaw in our logic. 0 times a number is the same thing as 1 times a number? Okay, so x is, remember, and this is where we got to be clear, x is representing a number. So pick a number just to try out. I don't know, how about 5? 0 times 5 and 1 times 5. 0 times 5 is 0. 1 times 5 is 5. Those are clearly not the same thing. You cannot say that those are the same thing. So unfortunately, what happens, or fortunately, what happens is they cancel each other out. And there's a simple way to think of it. They're opposites. And you've been using opposites for a very long time. Opposites will cancel each other out. We use opposites when we are solving equations, when we're doing lots of different things. Okay? Go ahead. Yeah, and we've got this negative 3 hanging out here. So this is going to be not plus, but will be minus. So we got minus 3. And so now we have successfully combined like terms, simplified, and written in standard form. Does anyone have any questions on how we did that? Catalina?
Wait, if you have parentheses, like remember the original equation and there was parentheses and there was a plus, instead of a plus, if there was a negative, we just said negative.
We're going to get to that. Yep, you're going to see that today. Any other questions? Okay, so part B. So again, the whole point of me doing that quick exploration about 2 plus 3 plus 5 and having parentheses and not having parentheses was just to help you see that even though we have two separate expressions and we're adding them together, the parentheses is just a grouping symbol. It's just showing you what really went together initially. But it doesn't have any purpose mathematically. It's just grouping. So now we're asked to add. Combine like terms, as Yasmin summed up for us. So can someone give us what we should do first? Where should we look? Amar?
6x squared, 3x squared,
I love how you found all three of them, and I love how you said negative 8x squared. That was really important. So very good job. And so now combine them together. Remember, combine like terms. We're not doing anything with the exponents because that's baseball and we're doing basketball, or however you want to view it. Go ahead.
Tell you what it is.
Yeah, go ahead.
X squared.
Yeah. You end up with just 1x squared, which we write x squared. Great job. What else? Paige?
combine negative 4y, 3y.
Negative 4y, 3y, and negative 2y. Again, I very much appreciate how you included the negative signs with it. And so what do you get when you combine those?
Negative 3y.
And so it's a negative 3y, and we just write minus 3y, and there's nothing left. And so that is in simplest form. Does anyone have any questions or concerns about what we did? Cheyenne?
I saw that there was like, it wouldn't make a difference
plus and then parentheses and then like the negative 2y or whatever it is, because then you would be adding a negative 1. Is that the same thing as negative 3y?
Say it again.
Like,
Say the beginning part again.
like, would it make a difference if the parentheses were there, but a plus sign was before it, and then it was like negative numbers after?
So parentheses negative 2x. There's a plus sign here, like that.
Yeah, plus like that.
Well, if I drop, I like what you're asking now that I understand. So if I drop the parentheses, that doesn't look very good, but it doesn't change the fact that that's really a negative 2x. So you just have to focus on what is the value here, and that's a negative 2x whether I have that there or not.
So
Okay.
parentheses could change the value of
It doesn't change it, but it just highlights it. It makes it clear. Okay? It's a good question. Okay? Any other? Go ahead.
So basically, this lesson is just like extreme simplifying.
Sure. I like the way you say that. Yeah, it's like exactly. So going way back. But you're going to see a couple things where we take it next level, but for the most part, that's it. That's why there was nothing new. Okay? I like that. You should patent that. License that. Trademark it. Whatever. All right, let's see how you do. Checkpoint number 1. You do not have to copy the original questions and checkpoints unless you need to. If you need to, then copy it. If you don't need to, then don't copy it. Doesn't matter whether you do or you don't. You got 4 minutes on the clock. See what you can do. Work individually, and then as you need assistance or guidance, or you want to compare your answers, that's when your teammates come into play. Wow. If you're already done and your teammates are done, then by all means compare your answers to see how you did.
Yeah, that's it. Like I wrote down your reason. I was talking about. We be talking about emergencies and then we be doing that. Like write down 1 plus 4 emergency. Like wait,
Okay? Pencils down, colored pens up. Here we go. For part A, I've got student 9, 14, and 12. Student number 9, what did you put? Hold on, I'm sorry. I apologize for cutting you off. I just want to make sure my students are listening and following along. Being respectful of their peers. Good. Go ahead, Keisha Pei. I apologize. Start from the beginning of what you said. Okay, wow, okay. Student number 14, what'd you put?
2x to the 6 plus 6x to the 5th plus 12 to the 3rd minus x to the 2nd.
Okay. Student number 12, what did you put?
2x to the 6 plus 6x to the 5th plus 12x to the 3rd minus x to the 2nd
I'll answer questions in a moment, but now let's get part B. I've got student 10, 22, and 5. Student number 5 is not here. Student number 10, 22, and 24. Student number 10, what'd you put?
A squared minus 3b plus 7.
Student number 22.
A squared minus 3b plus 7.
So I think that was the same thing. Student number 24. A squared minus 3b plus 7. Very good. Questions on either of these? Questions on either. Amir, you had a question? Go ahead.
Yeah, I have 2 actually. On the first one,
instead of adding them, I just put plus 13 plus 2. Is that correct or wrong?
Unfortunately, I would mark it wrong because the whole point is to put it in simplest form, and you didn't quite finish that process. But try not to think of it, when I say I would mark it wrong on a quiz. But right now you're learning, so I don't really care. I want you to walk out of the room knowing that when you simplify, you have to simplify everything that can be simplified. Do you know how to add 13 plus 2?
Yeah.
Then you should go ahead and add 13 plus 2, okay? And your second question.
Actually, I put x8 because 2 halves make a whole. And there's still the 8 there. That's too weird.
Okay, so you're talking about in part B, this 1/2 a squared and the 1/2 a squared?
Yeah, I was confused.
Yeah, well, but think of it this way, okay? Let's use a simple example, okay? Because this is really important. If I ask you to add 2x and 2x, what do you get? 4x. So whatever number is here gets added to whatever number is here, and you get 4x, right? And what if it was x plus 7x? What would you get there?
Oh, because there's an imaginary one.
There's a 1 right there, so you get what? You get 8x, but no matter what, you're adding the number here and the number here, right? You're adding the numbers. So how is that different when I do this? It's not. So 1/2 plus 1/2, as you already said, was 1 whole. But you don't put the 1. So you just write x. In the actual question, it was a squared. And a squared, we added the 1/2 to the 1/2, and we get a 1 whole right there, but we do not write the 1. Okay? So you already knew what to do. You just got a little thrown off by the fact that it was a fraction. Do you see now how it makes sense? Good. Excellent question. Any other comments or questions? Good. So no comments or questions, because now we're going to go to the next level, and we're going to answer Catalina's question from earlier, which is, what happens if there's a subtraction sign?
Jesse.
So I want you to think about, again, the fact that there were no notes. There was nothing new that I introduced today, which implies that you already know how to do this. But what I did say was new context. So now you have to take what you already know and apply it to something that looks maybe not quite what you're used to. But think of what Kayla said. All we're really doing today is extreme simplify. I love the way she said that. So it's not different, it's just taken to an extreme. So let me help you focus by doing this. Let's for a moment get rid of that, and just for a moment get rid of that. And let's focus on the subtraction sign and what comes immediately after it. What do you already know that you're supposed to do when you have a subtraction sign outside of the parentheses? Got 1, 2, 3, 4, 5, 6, 7 ideas? Go ahead. There's a 1 right next to it, so that's really a negative 1. Good, and so what do you have to do, Tyler?
You have to change, you have to switch on the sign.
That's right. So, but Catalina, you said something earlier that really what we're doing with this is what?
Distributing.
Yeah, you were really distributing it to everything, but Tyler's shortcut is a very effective, really good one, especially for advanced students like you. So what this means is everything flips. So watch. Flip, 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 flip. And I very intentionally use the word flip. I don't say make it positive. I didn't say make it negative. I said flip it. Flip means Whatever it is right now, make it its opposite. So if it's positive, make it negative. If it's negative, make it positive. And that's why I intentionally use the word flip. So now we have it correct, but now I want you to watch what really happened. It just turned into a big addition problem again. It's no different than what you just did. You just have to change one aspect, one set of expressions. You have to change their signs, and that's it. And just like we said before, the parentheses, now that everything's being added, the parentheses are not serving a purpose. They were when there was a negative sign, but now that we've finished with the negative sign, now the parentheses are not serving a purpose anymore. And so now do the same thing that we did already. Amari, go ahead.
I was gonna say, like, you still have the parentheses there and the subtraction sign for square. Would it still be the same thing that you just like realize from the subtraction sign or the parentheses?
You mean representing the distributive property? You don't have to do that.
Well, it's changed now, but
Let me come look at what you mean so I can understand. I don't want to confuse anyone. I want to see what you mean, okay? Just give me a couple of moments. All right? But so now here's where we're at. But we did do a change. We changed this right here. That all changed, but now that we executed the change, now we can go ahead and do what we've done before. Combine like terms. Where should we look first? What would make sense to look at first? Chanel? 11x to the fourth and x to the fourth. And another one right there. Combine like terms. So now you've done this 4 times already. You should be feeling pretty comfortable with this. So now we do 11, 1, and 1. 13x to the fourth power. And now just keep working your way down the exponents. Which exponent should come next? Since we're doing standard form. Michael? X to the third, and what are its partners? Doesn't have any partners. So we've got plus x to the third, that's done. What's next? Tyler? X to the second. X to the second. Any partners? Nope. Plus x to the second. What's next, Cheyenne?
The negative x.
The negative x.
And the negative 2x.
Very good. I love how you said the negative 2x. And what do we get when we add those?
I didn't do it.
Okay, well, negative x and negative 2x. It's a mental math problem, hopefully. Tristan? Negative 3x. Very good. And so we're done with this. And then, of course, left over is the 6, the negative 8, the positive 5. Go ahead, Laurel. So you get 3. So now we're here, and now you take all of them, and you've got to the fourth, to the third, to the second, so that's 7, 9, 10. So we'll get x to the 10th power, and now we do 13, 1, 1. That's 15, 18 minus 3, so we get 15x to the 10th.
Well, no, you don't.
I can't even keep a straight face. I couldn't even do it. I tried. Yeah, of course you don't do that. That's the whole point, is that you can't do that. Okay? So, any comments, questions? Any questions or concerns? So let's just make sure that we understand the subtraction sign, and we're not even going to do the whole question. We're just going to make sure we understand the subtraction. Subtraction affects whatever is either immediately after it or whatever is in parentheses immediately after it. So we are looking here only when dealing with this subtraction. And as Tyler so eloquently stated, we're flipping all the signs. But you got to remember to flip this. That's kind of the activator. That's what flips everything. So flip that, and then flip everything. This becomes a negative, that becomes a positive, that becomes a negative. Don't forget that first one right there. And basically what has happened is we've now used the parentheses. We've now used them. Now they don't really serve a purpose. Now we can combine like terms. We've done the combining like terms now 5 times. I mean, we got 7m to the 4th, negative 5m to the 4th, combine them. Negative 2m squared, 5m squared, combine them, and a negative 8. So we don't need to do the whole question to get the point. Any concerns about that? Good. So let's see how you do on your own. Simplify and write in standard form. You got 2 to simplify, you got 3 minutes. That's 1.5 minutes each. If there's time left when you're done, compare your results with the people on your teams.
So tired. Yeah, I know. Your baby's so happy. Why? Oh my gosh, I haven't had so many like that was amazing. Oh, don't get dog too dry. Just be very juicy.
Okay, so let's see how we did now that some of the polynomials involve subtraction. So for part A, I've got student number 10, student number 1, and student number 2. Student number 10, what do you say the result is?
Negative x to the 3rd power plus 4y.
Okay, and student number 1?
Negative x to the 3rd power plus 4y.
Student number 2?
Same thing.
So 3 of you think it is negative x to the 3rd power plus 4y. And part B, I've got student 21, 11, and 12. Student number 21, what do you say? Oh, hold on, I'm sorry, I apologize. Go ahead.
11, negative 11x squared minus 3x plus 16.
Okay, student number 11.
Negative 8x squared minus 3x plus 16.
So we have a difference of opinion. Student number 12, what do you say? So we get negative 11x squared minus 3x plus 16. So, any concerns at this point before we go next level? Any concerns or issues, any observations or patterns that you've discovered? Caleb.
Question: how did we end up with negative x to the 3rd if 2x to the 3rd times negative is going to be negative 2x to the 3rd? Then it's going to be added to. Oh wait, never mind. Where are you at?
You're part A. So here's where some people got thrown off. Minus, and now we just have one monomial, one term in the parentheses, but that still gets flipped. And so now we have a negative 2x to the 3rd and a positive 1x to the 3rd. You combine them, you get negative x to the 3rd. But I think you figured it out as you were talking.
No, I put a 3 in front of the x 3 the x to the 3rd. So, yeah.
Oh, just accidentally you put a 3? Oh, okay, that's fine. I can deal with that. You dash and then a mu?
Can we like when we write it out, you know how if it's like subtraction, can we just like write it right there like that?
Absolutely. If as you're writing it, you already know what to do. Yeah, just go ahead and write it out the correct way. Absolutely. Amir?
Oh, no, I see what I did. I didn't flip it. Like, yeah.
Okay, good. Any other comments, questions? Good. So now the whole point of this is not to be able to sit in a classroom and just combine things because I tell you. It's because of research and studying our world. The next example is going to be hard for you to understand where certain things come from. So don't worry about that. We're going to talk about that. But I just want you to read to yourself. Read to yourself. So, how is it possible to be talking about farmland and end up with a polynomial that looks like this and another one that looks like this? Well, I'm not talking about how that was created yet. We're going to learn, you're going to see in a couple of weeks, actually next week, you're going to see how you can represent an area using a polynomial. So I'm not worried right now about where that came from. But right now I'm worried about what we can do. And so what we have is a farm. And one plot of land is on one side of the farm and the other plot is on the other side. And so you can look at them separately, but then you can also look at them together. And so we're asked to write a polynomial that represents the total area. So what are we asked to do? What are we asked to do, Tristan? What did you think, Chanel? Add them. So the word total should mean something to you. Total means, okay, put them all together, add. But now I want to talk about, it says write a polynomial. What it really means is write a simplified polynomial. So watch what happens. Plot A is represented by this. Plot B is represented by this. If we put them together, we'll get a new expression that represents the whole plot of land, all of his land. So we've got 3x squared plus 7x minus 5. That's a plot of land. But we're going to add the second plot. Anyone notice anything about the two polynomials? If you compare them with each other, anyone notice anything?
They both have it's like they're easy. They're gonna be easy to combine like terms.
Okay, why? What makes you think that they're easy?
Because it's only like I can't explain it.
Okay, that's fair. Michael, and then we'll go to the back. Say it again. Okay, they're both in standard form. Very good. Imari? Okay, they all go together. Okay, Catalina?
And like, they all correspond.
Oh, that's an interesting way of saying it. They correspond to one another. Interesting. Tristan?
They're in the same place.
What's in the same place?
Like 3x squared is in the first place.
Hold on. Listen to what he's saying.
Like 3x squared is in the same like as the first one, and then we see the like term 5x squared. That's the first.
Very good. So watch this. What if we did this as just a way to do things a little bit easier? Didn't you learn in elementary school to add like that?
Yeah.
And so if you add straight down, if everything's lined up already, why not add straight down? That, and then that, and then that. Everything's perfectly lined up. So now, and everything's being added, so you don't have to worry. 3x squared and 5x squared is 8x squared. 7x and negative 4x, 3x. -5 and 11 is 6. And because we stacked them up so effectively, we've got the simplified polynomial. Would we have been able to do it the other way? Of course. So here's another possible technique for you to use if you'd like to. Will it work in every case? Will it be efficient in these cases? Will it be efficient in this case? Probably not. But as Michael said that they're both in standard form, and I like how Catalina said they kind of correspond to each other, and Tristan said that they kind of are in the same position, the like terms. So it was very easy to stack them up. And now we have an expression. This polynomial represents all of the farmer's area. Does anyone have any questions about that? Okay. Now, what if it said, instead of total area, what if it said, write a polynomial to represent the difference between the two? What if I put the word difference there instead of total? What would you do then? Kate? Okay, what were you going to say, Kayla?
Subtract them.
Subtract them. So the words that are used affect what you do, so you have to pay attention. That's why I honed in and focused in on this term right here. Okay? We do have a checkpoint, but I'm very low on time, so we're going to skip over the checkpoint, which is fine. And we're going to go to the homework, so draw a line across your paper. Your homework is page 347, numbers 1 through 14. Question number 14 has 2 parts. It counts separately. Make sure you read instructions carefully. Total of 15 questions, and you will have a quiz on 6-4, so I have you tomorrow and Monday. So it's going to be Monday. That will be on 6-1, 6-3, and 6-.